Good day, all of you, my dear student in Alahram Model School. We welcome you all, and we have a new session of revision. This is the third revision. Today we're going to talk about the operation on natural numbers. We will talk about the properties of addition. There are four properties of addition. The first properties in addition, we call it the closure. Closure, it means if I add two numbers that they are belong to the set of the natural number, so the answer definitely is going to be belong to the set of the natural number. For example, if I have 3 plus 5, 3 belong to the natural, 5 belong to the natural, so the answer is going to be 8, and 8 also one of the elements of the set of the natural number. The second one, we call it the commutative property. When we change the places, when we change the orders, here I will add first a plus b. That will give me the same answer if I start with b plus a, and b and a is any number that's belong to the set of the natural number. So this, we call it the commutative. The third properties, we call it the associative. When we have a set of group of numbers that belong to the natural, if I put a plus b between two brackets and I get the answer and add it to c, this will give me the same answer if I add b plus c, put b plus c in a bracket and add it to a. The value doesn't change in these two parts. We call this is the associative property, and we're going to learn more about it when we solve exercise about these properties. The last one is the additive identity. The additive identity, when we add any number to 0, the value doesn't change. So 5 plus 0, that will give me 5. So we call this the additive identity or the additive neutral element. So we're going to solve exercise on page 16. Exercise number 1. The additive neutral element. He asks you, what is the additive neutral element in the natural? So you call me Miss 8 number. Yes, 0. Very good, all of you. Now we have another exercise. 213 plus 57. That will give me 57 plus space. This is easy. First, cross the same number. Search for the same number. Here I have in this side 57, so I will cancel it and cross also 57 in the other side. What is left here? 213, so I'm going to write it in this empty space. As you notice here, I change the places, so this is called the commutative property. Yes, my dear student. And another one. Now we have a group of 3 numbers and we have a bracket, we have a home here. So so easy, cross the same. Here I will cross 28 with 28. In the other side, I will cross 59 with 59. So the number here 72, I'm going to write it in this empty space. And as you see, this is a bracket, this is home. So this is the associative property. Exercise number D, 213 plus 17. Here is addition, so get the answer of the additions because I don't have any sign in the other part. So 213 plus 17, that will give me, yes, 230. So these numbers belong to the set of the natural number. So this is property, we call it, yes, the closure property. The closure property. The last one here, 351 plus 0. When we add any number to 0, the value doesn't change, the number doesn't change. 351 plus 0, yes, it will give me 351, and we call this is the additive identity. The additive identity. Here I can write it the additive identity, or I can write it the additive neutral element. They are the same and they are both correct answers. We have more exercise about it. Exercise number 2, use the properties to find the result. Here I have 71 plus 257 plus 29. My dear student, the idea is here is to look at the number in the units place. Here I have 1, here I have 7, here I have 9. So what I'm going to do with these numbers, search for 2 numbers. If you add them together, the answers, it will give you 10. So you will say, Miss, this one here, if I add it to 9, the answer is going to be 10. So my dear student, let's change the places. Let's change the order of this operation. So here I will write 71 plus 29. I'm going to put it here. So 71 plus 29 plus 257, and please write the properties that you use. You change the places of this number, so you use the property we call the commutative property. So the next step is going to rewrite it again, the same number, but put 71 and 29 because this number will give me 10, so I put it inside the home or inside the bracket, and I call this property is the associative property. Okay, what is the third step, miss? Get the answer of the number inside the bracket. 71 plus 29, it will give you 100 plus 257. This is give me 357, and this property is a closure because all of these digits belong to the set of the natural number. Okay, I hope you understand this exercise, and we're going to have more operation on the set of the natural number. We're going to talk about the properties of multiplication. When we do a multiplication operation, what are the properties of multiplication in the set of the natural number? Yes, the first one, closure. I know that you are all understand the meaning of the closure now. Any two numbers, if I multiply them together, the answer also is going to be belong to the set of the natural number. For example, if I have 2 plus 3, that will give me 6. 2 belong to the set of the natural number, 3 belong to the set of the natural number, and the answer 6 is also belong to the set of the natural number. And we told that the commutative, it changes the places. When we change the places in the multiply, the value doesn't change. When we do the bracket, when we do the associative, same as addition, also the value doesn't change. Now we have another thing, another property, we'll call it the multiplication by 0. Any number, as we studied, my dear student, multiply it by 0, the answer is going to be 0. Okay, so any number, when we multiply it by 0, the answer is going to give me 0. So what about the multiplicative identity? The number which doesn't change the value in the multiply, it's number 1. When you were young, we told you that 1 is a mirror. So here we call it, we are in primary 6 now, we call it the multiplicative identity, the number which doesn't change the value of multiply. Okay, the last one we call the multiplication distribute over addition. We're going to have also told you that when we multiply a times b plus c, first multiply a times b between two brackets, then put the plus sign, and then multiply a by c. Okay, let's have exercise to make us more understand these properties. On your page 17, first complete the multiplicative neutral element in the natural. Here we'll talk about the multiplicative. Please, my dear student, read it carefully before you answer this question. This is so easy, by the way. Multiplicative neutral element, the multiplicative identity, the number who doesn't change the value. So yes, all of you clap your hand for yourself. This is number 1. Okay, another one, 46 times 25 give me 25 times space. Here I have equal sign and I have to same number, so cross the same number. I will cross 25 with 25, so 46 I will write it here in this empty spaces, and this is, I change the orders of these two digits, so I will call this is the commutative property. Another one, here I have 4 times 17 times 5, 4 times 5 times space, yes, cross the same number, cross 5 with 5, 4 with 4. What about 17? Can't write it here in this empty space, so here I put brackets, so I use the associative properties. Okay, number D, if I multiply a times b equals c, a belongs to the set of the natural, b belongs to the set of the natural, and the product here also belongs to the set of the natural number, so we call this closure. Yes, my dear student. Another exercise, and exercise D and E, they are the same idea, but here he used symbols and here he changed the symbols into numbers, into digits. So 3 times 5, that will give me 15, and they are belong to the set of the natural, so we use this property, we call it the closure property. The last one here, 130 times 1 give me 130. The value doesn't change if I multiply, even when I multiply it by 1. So we call it this, yes, the multiplicative identity, or I can call it the multiplicative neutral element. Okay, let's have also another exercise, how to use the properties here to get the answer. Okay, as I told you, the idea is to make the multiplication operation easier for you. So search for two numbers. If you multiply them together, the answer is going to be 10 or 100 or even 1000. So here in this exercise, means when I will multiply 5 times 2, that will give me 10. So my dear student, let's change the place of 2. Let's get 2 near to 5. So here I have 5 times 2 times 38, and I change the places. I call this property is commutative property. Now what shall I do? Put 5 times 2 between two homes, between two brackets. So here I have 5 times 2 times 33, 38. So this is the associative property. The last step is to get the answer. 5 times 2 give me 10, 10 times 3, 38, it will give me 380. Okay, now 25 times 6 times 4, so 25 times 4, that will give me 100. So change the places of 4 to become near to 25. This is we call the commutative property. Then yes, rewrite it again, but put 25 times 4 between two home, two bracket. So 25 times 4 times 6, this is we call the associative property. Now get the answer. 25 times 4, that will give me 100 times 6, that will give us 600. Okay, now we have another thing that we're going to make a revision. It's the geometry. Today we're going to make a revision about what is the perimeter of any shape and the area also of some certain polygons that we studied before. So the first thing that I'm going to make a revision is the perimeter. And the perimeter of any polygon or any shape is the sum of its outline shape. The sum of its outline shape. For example, if I have a square and ask you to calculate the perimeter of the square, all you have to do, you said, Miss, square have 4 sides, and any square has 4 sides and they are equal in length. So the perimeter here equal length times 4 or side times 4. So what about the perimeter of the rectangle? So easy. First add the length plus the width, the 2 dimensions of the rectangle, length plus width, and the answer multiplied by 2. So again, the perimeter of rectangle equal length plus width all times 2. So what about if I want to remember the rules of the area of the triangle? Okay, we studied that triangle is one of the polygons that has 3 sides and 3 bases. Each base of the triangle has a corresponding height. For example, if I have this triangle and I draw a line segment that join the vertex here with this corresponding base, so this is, we're going to call it the height of the triangle. So the area of the triangle equal half time base time height. Half time base time height, and the base he will give it to you in the exercise, and the corresponding height he will give you the length of it, and you going to write the rule here, area equal half time base time height. What about if he asks you to calculate the height? Hide the height here, so area divided by half time base. Okay, now we're going to have also the area of parallelogram. This is so easy. Area of parallelogram, base times height. Base times height. Okay, what about the area of rectangle? Okay, this is also so easy. Equal length time width. Please remember these rules because they are very important. So area of rectangle equal length time width. Now we're going to remember the area of the square. I have 2 rules to calculate the area of the square. The first one, as we studied in primary 4, so area of the square equal side length by itself or side by side, area of the square, side by side. But if he give you the diagonal length of the square, and remember that the diagonals of the square, they are equal in length and perpendicular. So the rule here is going to be area of a square half time d time d. D is the diagonal length of the square. And the rhombus also have two rules. First, area of the rhombus equal length time height, and I have another rule in the term of its diagonal. And remember, my dear student, that rhombus has two diagonal and they are perpendicular, but they are not equal in length. So here I have to put D1 and D2. So area equal half times D1 times D2. Half times D1 times D2. If he give you the area and he asks you to calculate the, let's see, the length of the second diameter of the rhombus, so height D2 here, and the left is A divided by half time D1. Okay, now what about the circumference of the circle? Because circle is a very special shape, we're going to call the perimeter of this, or the sum of the outline of the circle, we're going to call it here, this sum of the outline shape. Here I'm not going to call it the perimeter, I'm going to call it the circumference of the circle. So when I ask you to calculate the circumference of the circle, it means that I want to calculate the perimeter is the sum of these curved lines that form the circle. So as we studied that any circle has a center point that we call the center of the circle, and the line segment that join between 2 points on the circle that passing through the center of the circle, we call it the diameter of the circle. Means why you give me the diameter here? Because my dear student, when you calculate the circumference, you need the diameter length. So the circumference here equal pi times d. Means what is pi? We said that pi is a ratio that he will give it to you in the exercise. It equals 3.14 or 22 over 7. So he will give you the ratio of the pi in the exercise. And we have another rule also to calculate the circumference. If he gives you the radius length here. Radius is the line segment that join between the center of the circle and 1 point on a circle. So we call it this line segment, we call it the radius. And remember, the diameter equal 2 times radius. Here is the diameter equal to r. So when he gave you the radius length, you can calculate the circumference only by multiply 2 times pi times r, 2 times pi times r. And as we said that the pi is a ratio, it equals 3.14 or 22 over 7. Now let's have exercise on page 21. He wants you to choose the correct answer. The area of the triangle whose base 10 and the corresponding height is 5. Okay, means I'm going to write the rule. Yes, area of triangle equal half time base time height. Means I have the base here 10 centimeter and I have the corresponding height 5 centimeter, and I'm going to make half 0.5 times 10 times 5. That will give me 25 square centimeters, so the answer is going to be 25 square centimeter. Okay, another one. A circumference of a circle equal 22 centimeter. Then the diameter length. He calculates the circumference and he asks you to get the diameter. So what shall you do? First, write the rule. The circumference of the circle here equal pi times d. And I use the below that have the diameter because he wants you to calculate the diameter. So circumference equal pi times d, but here he asks you to get the diameter. So the diameter is going to be c divided by the circumference here is 22. So 22 divided by equal 22 over 7. That will give me 7 centimeter length. Okay, so diameter here is going to be 7 centimeter length. What about the exercise number 4? The area of the rhombus whose diagonal 10 and 6. 10 and 6. The rhombus. Here I have two lengths of the diagonals because they are not equal. So I will use half times d1 times d2. Half times d1 times d2. So d1 is 10 centimeter. d2 is 6 centimeter. I'm going to multiply it by 0.5, which is the decimal form of the half. So the answer is going to be 30 centimeter. Okay. Here I have the circle which length of the greatest chord is 14 centimeter. What is the greatest chord of any circle? Yes, as we studied before, that the greatest chord of any circle is the diameter length. So write the rule, the c equal pi times d. pi equal 22 over 7, and the diameter he gave it to you in the exercise 14. So 14 times 22 over 7, that will give me 44 centimeter. So by the end of this, we come to reach our third revision. I hope you understand it, and I'm waiting for any question for you to help you. Okay, my dear students, see you next time. God bless you all. Goodbye.